good morning in Americas. As Sonia said, thanks for all of you joining us from different countries. Here I have Albania, Australia, Brazil, China, Costa Rica, Hungary, India, Indonesia, Ireland, Italy, Malaysia, Morocco, Peru, Philippines, Poland, Portugal, Qatar, Saudi Arabia, Spain, Tanzania, Turkey, United Kingdom, and United States. So many people from different countries. Okay. I am here in Republic of Ireland, and my affiliation is Technological University Dublin. As you can see from this slide, I am associated to different research centers here in Ireland. Most of them are in artificial intelligence. Some of them are linked also to human-computer interaction and human factors. See if it's working here. Okay. So today, as Sonia said, we will be talking about empowering qualitative research methods in education with artificial intelligence. So the first things I would like to do is to quickly explain what artificial intelligence is with a game. And there are a lot of misconceptions about artificial intelligence and a lot of imprecision. So I want to put this straight. Then we will be talking about qualitative research methods and how artificial intelligence can empower qualitative research methods. Then I'll define education very broadly, and most of you probably are in education, maybe teachers, learners, and you know, some principle, some pedagogical principle for example, design instructional material for different level, university, high school, primary school, intermediate school, and so on. Then I will talk about how artificial intelligence finally can empower education and can empower us as instructors. Okay, so let's start first with artificial intelligence. Probably most of you have heard this. We can hear this in newspaper, radio, television every single day. But artificial intelligence is a very, very specific discipline. I got some definition from different sources online, books. For example, some say a branch of computer science dealing with the simulation of intelligent behavior in computers, the capability of a machine to imitate intelligent human behavior, intelligence demonstrated by machines in contrast to the natural intelligence displayed by humans. There are so many definitions online you can find, but I got these three because they share something. And what they share is exactly a couple of concepts, which is intelligence and machine. So the goal of artificial intelligence is to study human intelligence with artificial artifacts, what we call machine. And through this, we can construct machine, we can construct computer programs, we can construct artificial artifacts that in turn, in a loop, help us understand human intelligence. So I would like to explain this with a game, and this is called the Turing test. The Turing test was conceived by Alan Turing. Probably most of you know who Alan Turing was. He was a logician in UK, and in the Second World War, he helped the UK government to decrypt the Enigma German machine, which basically were means to communicate across countries in Europe in a form that was crypted. So even if someone could catch these messages, they couldn't understand a lot of things because they were crypted. And Alan Turing, as a logician, as a mathematician, helped construct a machine that was called Enigma that was able to decrypt these German messages and anticipate their moves. And it is believed that the war finished 2 years earlier thanks of this invention. In 1950, he wrote a journal paper And in this journal paper, he proposed, published in the journal Mind, he proposed a question: can machine think? And it is believed that artificial intelligence, as we know now as a discipline, was born in those years. So he was a very brilliant mind, and in order to explain his conception of artificial intelligence and to answer this question, can machine think, he invented the Turing test. Some of you have watched probably the movie The Imitation Game, and the Turing test is exactly an imitation game. So imagine we are, for example, as me now, sitting on a sofa and interacting with a computer. So we have a person P interacting with a machine, with a means for communication, for communicate with other people. In the middle, we have a big wall that separates me from all the world. And then on the other side of the world, we have two things: one machine and one operator, one human operator, O. So the Turing test, so the imitation game, the Turing test is this one. The operator start asking questions with the computer, and this question in turn are sent once to the machine and once to the operator, human operator. In turn, these two entities answer back the answer to the operator P. And basically the Turing test says if the operator P is not able to understand when the answer comes from the machine and when the answer comes from the operator, it means that the machine is capable of reasoning, learning, and proposing answer to the person P in the same way as human. So we can actually say that the machine M is actually an intelligence machine. So can machine think can be translated into another question. Can we build machine that have intelligence as human in order to cheat the operator P and let him, her, and not understanding when the answer comes from? So with this imitation game, which I think is very powerful for explaining artificial intelligence, we can move on. And again, we can start answering this question: can machine think? So in order to build a machine that has human intelligence, we need to build a machine that is able to perceive things. So is able to understand touches, smell, tastes, vision, hearing. So is able to get input, sensory input from the environments and perceive what's going on. We need to create a machine that is able to represent knowledge, because all these inputs needs to be represented in an organized way, and this information need to be structured in a way that can be translated into knowledge. Then the machine needs to be able to learn from inputs, needs to be able to learn from the environment, and so it needs to learn automatically. It needs to be able to reasoning. So giving the inputs, given the representation of knowledge and the reasoning, and the learning, can we actually create a machine that is able to take all these things together and start arguing, and start reasoning, and start deducing things? We need to be able to construct a machine that is able to plan, to suggest us the best action for our decision making. And eventually we need to create a machine that is able to implement, to process, to perform natural language processing, because in the previous game, the imitation game, we need to compose answer and give it back to the operator. So all these characteristics are what we call artificial intelligence, because these are subfields of artificial intelligence that form this discipline as a whole. And in fact, perception, knowledge representation, automatic reasoning, automated learning, planning, natural language processing are all goals that artificial intelligence try to achieve. So if someone asks you, okay, artificial intelligence is machine learning, that's not totally true, because machine learning is just a part, it's just a goal that artificial intelligence try to solve, which is in this case automated reasoning. So artificial intelligence is bigger than just machine learning. So now that I have introduced in short terms what artificial intelligence is, let's move on and start discussing about qualitative research methods. So these are scientific methods of observations that make use of non-numerical data. For example, text, images, audio, and video. These do not contain numerical observation. And the focus here is to understand why and how a phenomenon takes place. And our goal as qualitative researchers is to understand the meaning of concept, the features, the attributes of the things we observe, and try to define them. And as you can see, these things are not grounded on the occurrences, frequencies, and measures of things, are more qualitative. Most of you probably have play with participant observation. You go in a room and you observe people in their natural environment, acting, performing tasks in the unnatural environment. Some of you has taken some of these people and perform in-depth interview because you want to qualitatively try to understand from their perception and from their description what was going on, for example, during the task with the others. And then we can do focus group. All these are the most used, the most employed research method that qualitative researchers use. So the goals of these are to explore research hypotheses about a particular phenomenon rather than confirming them. So we start with qualitative research methods. A lot of people think that qualitative research is a little bit weak, and we should always try to do quantitative research. But qualitative research is very important because it helps us to define quantitative research hypotheses. So most of the times, without initial qualitative research, we cannot do quantitative research. So the goal is to describe the variation of the things we observe. The goal is to explain the relationship between the things we observe, and above all, try to understand and define and formalize individual experiences and group norms. So in order to perform qualitative research, we have some research methods, and these are data analysis methods, as well as we use them within quantitative research. The most important is probably coding. So we observe something, we hear something, we record something, and we code. And this is a process which is very systematic, which is very strict. And the goal is to summarize what we observe in written form. Because when we, for example, interview people, we have verbal material, and we need to formalize, we need to code this in a written data that we can then use for further interpretation and manipulation. And the goal also to summarize in simpler terms what we have observed. Coding is also a set of procedures for the rigorous investigation, analysis, and verification of the content. And why we want to do this? Because we want to allow other qualitative researchers to replicate our experiment, and from their side to perform validation and create valid inferences. So it's very important, the role of a qualitative researchers, because data is the first step of structuring data that are unstructured, that are scattered, that are raw, and we start giving a shape. So the goals of coding is, for example, to segment text, to categorize text, to allow researchers to perform content analysis, to synthesize material, observation, and to allow the initial development of research hypotheses that, for example, can be further investigated with in quantitative terms, and as a second step to allow researchers to define theories. For example, some of you have has performed discourse analysis, because words as verbal material carry meaning, but also the context in which this discourse take place carries meaning and carries semantic. So if something is said in a certain location, can have a totally different meaning and semantic than the same thing said in a different location. We have a visual media analysis. So the same as and words, visual media carries meaning. Videos carry semantics. Videos are a sequence of images that evolve over time, and through this evolution we can extract the semantic and we can understand better the context and the role of the image we observe. I guess most of you have also played with grounded theory, which is a methodology for developing theoretical material. It's a methodology for developing theories that are grounded in data. And this data must be systematically, strictly gathered and analyzed. So what is the sequence of steps that we need to do for within grounded theory? So we start with our theoretical sampling. So we sample material through observation. We observe and then we sample it. So we give it a shape as images, video, textual material through coding, which is the second step. Then we start, once we have material in written form, we can start chunk this. We can start split this in smaller chunks of information. And then we start categorizing this chunk of information, and we start giving meaning, and we start understanding the semantics. And then from this, we can finally extract knowledge, and we can start defining the concept and the relationship among contexts. And then we loop until we reach saturation, until we don't have enough material to extract more knowledge. So this grounded theory, the goal of grounded theory is to, from raw information, turn this into knowledge, and from this knowledge to turn this into research hypotheses, and eventually and hopefully to theories. So let's see now how qualitative research fits with technology. So the pro of qualitative research is, A, they are good for, as I said so far, setting preliminary research hypotheses and to extract qualitative, rich knowledge. The cons, which is the main drawback we have now within qualitative research, is that we take a lot of time to collect material. It's low data collection and is very time consuming to analyze this information. But if we use technology, then technology are less intrusive. Data gathering technology. We have a lot of sensors nowadays that can gather verbal material, images, videos, audio, physiological responses of the body, and so on. And they are less intrusive because we don't really need to. They are, for example, we have wearable technologies, and this nowadays is no longer a problem. We can actually place these on our body and or cameras everywhere in different contexts, and we start collecting a rich set of data. They are very fast, so this solves one of the cons of qualitative research. Above all, they are higher dimensional, because if we place a camera or a microphone and we start collecting video and audio, we have way more information than a human observing another person. And above all, with technology, we can have larger sample sizes. So with a small sample, we can actually perform and achieve better inferences and a stronger, more robust finding. The cons is, again, larger sample size. But why this is the cons if it is also a pro? It's a cons because with larger sample size, now we have a new world of data analysis. With all this material that we have, we need to start using other research methods. In this case, we need to move from qualitative research to quantitative research and try to borrow from quantitative research methods some of the best techniques, some of the approaches to analyze these multidimensional large data. What is the solution, you might wonder? And this is exactly artificial intelligence, is exactly the use of the advances, the technology that we built so far within artificial intelligence to help us as qualitative researchers to solve our problem. So I have introduced so far artificial intelligence with the Turing test and the imitation game. I have explained to you what are the main goals of artificial intelligence, which coincide with the subdiscipline of this new fast-growing field, which is artificial intelligence, and how we can use this to enhance us as qualitative researchers. So AI empower qualitative methods because we have perception. Perception is one of the goals of artificial intelligence. So for example, imagine we have to deal with deaf participants. They cannot speak. So the only way to communicate is through gesture. As qualitative research like me, I don't know anything about reading gesture. But if I place a camera in front of the participant and I start making questions to this deaf participant, and then I take this video and throw in, for example, a model that is able to recognize the gesture and extract knowledge, then the algorithm, the model, can perform a sequence of gesture and translate in a written material for us. So it's way easier in this case to perform, for example, an interview with a deaf participant by using artificial intelligence. Knowledge representation, perception. For example, we can, artificial intelligence through perception can help us performing automatic transcription. We have our mobiles, and everybody is using voice recognition system, for example. So we can actually get the audio from a participant, use a software that translates automatically this to in a written form. Perhaps we just need to double check if the written material contains some type or some information, but this is way faster than our self-coding. And this technology is already mature. We can use any speech synthesizer and is ready to go. We can do the same emotion recognition, because if we have a video and we have an algorithm to recognize emotion in the face of a person, we can have a way richer set of material that can be used for our qualitative analysis. And as you can guess, the algorithm is way faster than humans. We don't want to sit down and analyze 1 hour video and annotate every single emotion and every single transition from sadness to anger to surprise of the participant. The machine can do this for us continuously, faster and in a more precise and systematic way. Now, if we move to the second goal of artificial intelligence, the second subdiscipline of artificial intelligence, which is, as we say, knowledge representation in the previous imitation game, AI can help create semantic networks. We remember we coded, we extracted concept, and now we need to try to assign a relationship among concepts. But artificial intelligence can do this for us automatically. And the output of this is a semantic network. So a set of concepts linked together by some other concept or relationship built in a graph. And as human, as qualitative research, we can interpret visually this graph and we can actually extract meanings. And this is way faster than doing this manually as humans. Artificial intelligence can help us building ontologies. We have a lot of concepts and we want to organize this multidimensional concept with a structure, and we need to define syntax and semantics. So artificial intelligence can start doing this for us automatically. We throw all the material, all the concept we learn, and the algorithm, the machine learn from us, for us the relationship, and present us again with a hierarchy, organized hierarchy, that we can actually interpret, refine, and finally better organize knowledge. And as you can see, again, the speed of organizing knowledge is way faster than doing this manually. Same with taxonomies. So not only we can organize knowledge, but we can actually extract rules and relations. Rules are a set of premises, a set of reasons linked to a conclusion and a claim. And from this, as you can imagine, we can start extracting research hypotheses, because we keep observing that all the dogs have certain attributes, and therefore is always the same, and we can extract a rule. If the dog has these features, then it must be a dog. And we can start linking things together and organize again knowledge, represent knowledge as a taxonomy. Let's move now to automated learning. Automated learning is what they call machine learning. It's nothing new. Machine learning exists for the last 50 years. It's nothing new. And again, machine learning is not artificial intelligence. Machine learning is just a subfield of artificial intelligence. But it's very powerful, and probably is the most advanced subfield of artificial intelligence, simply because we have now access to very powerful computers that are very fast in performing their tasks and executing their algorithms. And for example, giving a bunch of words, a bunch of text that, for example, we coded or another algorithm help us code, we can start clustering these words and we can start giving importance to these words, and we can perform word clustering. And once the machine gives us, for example, a scatter plot with words and the links and the weights, we can start discovering pattern in an unsupervised way. And we can start trying to, again, extract a relationship in this cluster of words. Automatic learning can help us extract sentiment discovery. As I said before, giving an image, this is connected to perception. Given an image, we can actually investigate the emotion in the face, and we can extract sentiment. And as I said before, it's way faster doing this with a machine than humans. We don't want, again, to sit, observe the person for 1 hour, chunk this video in smaller, identify every time the person, the participant, change face and expression, and then assign manually a label of sentiment. The machine can do this automatically for us. And again, is way faster than human. Imagine we have a video of 1 hour with a list, a sequence of variation in sentiment. This is a very powerful and rich information to study the participant. Automated learning, machine learning can help us categorize text because giving a document, we throw it, for example, in, there are many existing machine learning models that are able to assign to a bunch of words a category. This text is talking about technology, sports, entertainment. And this is there, is out for use, and we can, it's easy to implement. The only things we need to give to the algorithm is a bunch of words. So we can perform automatic classification instantaneously. Image categorization. These are pictures of brain tumors. And we are not expert in this, but the doctor, the radiologist needs to interpret this image. Some of them are easy to interpret, but even the radiology is prone to error because grade 2, grade 3, grade 1 are very similar, but the machine learning can help us extract very rich information in a, for example, in a specific location of the image, which our human eyes cannot always spot. And they are way more accurate than humans. And again, they are way faster than humans. Let's move on now to automated reasoning. Reasoning, as I said, is a very important attribute to our human intelligence. And once we have a graph of knowledge, once we have taxonomies, once we have ontologies, once we have organized knowledge, we can start performing argumentation. This is also linked to what I said before, discourse analysis. What are the arguments within a discourse? So there is a discipline within argumentation, within artificial intelligence, that is called argumentation. And it helps us build arguments, which are, let's say, symbolic rules of premises and conclusion that are linked together in a dialogical structure. And this can help perform reasoning, and above all, reasoning under uncertainty, when we have partial knowledge, where we have fragmented knowledge, where we have uncertainty. And this is very, very important things because it avoids subjectivity. It avoids our subjectivity as human performing qualitative research, and allows to more systematically extract arguments and help us understanding what are the pros and cons, for example, of a dialogue, and what are the arguments and counter arguments of two people or two politicians with different parties, and so on. Unfortunately, automated reasoning is one of the less developed subfield of artificial intelligence. Artificial intelligence actually started before machine learning started with automated reasoning. So probably some of you knows about expert system, knows about the fuzzy system and fuzzy logic. These are all old concept within artificial intelligence. Then in the 70s, 80s, with the advances in technology development, we started having more powerful machine, and then machine learning kicked in. But I think today machine learning is reaching the top, and is in terms of benefit is slowing down. And reasoning, automated reasoning, I think is going to be the imminent future for artificial intelligence, because these will help us create machines that actually exhibit intelligent properties. We move on now to planning, which is the fifth subfield of artificial intelligence, and this helps us planning action. What I'm going to do if I am in this state with this information, what I'm going to do if I am in this state with this other information. So our artificial intelligence can help us, can propose to us a set of action with different importances, for example, and can actually help us in our decision making, can support, can enhance our decision making, because there is quantitative knowledge that back up our decision making. Then, for example, in education, there are studies out there that help us learn paths of formation of learning material and suggest us how to realize certain pedagogical strategies. And this started coming out in the literature. And then we have our beloved natural language processing. And this is very powerful when most of us have text, because from text, we can extract topics, what this article is talking about, what is the underlying topic. As humans, we can do this, but we need to read the whole text. But we are humans, we are prone to errors, and subjectively, we can assign topics differently than another researcher. So there is no objectivity in this process. Artificial intelligence can help us solve this problem, can do it automatically, systematically. He uses a lot of probabilities to assign a specific topic, because the algorithm, the model, the natural language processing models have been trained with millions and millions of texts. So they know when the article is talking about sport is because there are certain words and certain sequences of words that are actually related to sport. And as you can imagine, it is way faster than humans. So as a qualitative research, our job will be greatly enhanced, because we don't need to focus anymore on doing all these manual labors, manual activities, but we can focus on the actual knowledge extraction. So I completed now, and I show you how artificial intelligence can empower education and help us as a qualitative researchers to perform qualitative data analysis. Now, let's move now to the last bit of this presentation, which is how artificial intelligence can empower education. I have defined artificial intelligence. I've given you some example of qualitative research and the methods we use in qualitative research. And now I want to define as precisely as possible education. Most of us are teachers, but teaching is, as you might know, is strictly connected to learning. So how can we be a good teacher, good instructor, if you don't actually learn? So the role of a teacher is to deliver instructional material to support and enhance learning of learners, of students. In order to do this, we must understand first what learning means. In education, there are different learning theories. There are hundreds of learning theories, but most of them belongs to four main categories. One is behaviorism, one is constructivism, one is cognitivism, and one is connectivism. Most of the learning theories that you might find in the literature can be underpinned, can be categorized in one of these four main theories. So let's go quickly through this. Probably most of you already know this material, but for completeness, I would like to present this. So behaviorism is when behaviorists think that learning, human learning, occurs when new behaviors are acquired by association between stimuli and responses. So we create an instructional material, so we create a set of stimuli, we throw this to the learner starts getting this information, and then we can observe the response of the learner. If the response of the learner is aligned to our expectation, then it means learning is actually happening. We have cognitivists. Cognitivists think that the learner is an information processor, but it's like a kind of a black box, because they think that the mind is a black box. And in order to understand how human learning occurs, we should understand how the mind works. We should open and understand this beautiful machine that has been assigned to us. Constructivist thinks that a learner constructs own perspective of the world according to individual experience and the internal knowledge, the prior knowledge we have. So we construct information by playing, like when we were kid, we play with the Lego. We just sitting on the floor, we have a bunch of scattered pieces of Lego, and we start constructing things, and we start learning. And while we learn, we start creating internal representation of information of the world, and we start getting experience. And according to constructivists, we evolve by constructing information in natural environments. And then we have a new learning theory, which is the connectivism, and this recognizes the impact of online connection, thanks to we have internet, between people and the use of technology. And while interacting with other people through digital means, and while we connect with people, but also with sources of information, we can actually learn and we can actually support our learning. So I tried to summarize this, and now I want to show how we can link everything we said with artificial intelligence with the learning theory. This is my vision because I am an instructor. I work in university, so I teach to master students, to PhD students, and I really would like them to learn. And I am a researcher in artificial intelligence, but I'm also a pedagogist. So my question has always been, how can I go to my class and apply methods, techniques, approaches, paradigms from artificial intelligence in my classroom and support the development of instructional material in a way that actually enhance learning? But I don't want to code this myself. I don't want to do this myself because it is a never-ending process and I'm not going to achieve my vision. So imagine we're in a classroom and we instead of sitting on chairs in desk very aligned, we are in a more relaxed environment where everybody see everybody around a circle table, and we place in this room different cameras. These cameras can actually point to each person and can actually point to each face of the person, but can actually gather the relationship, the interaction among these people. And imagine also each person has a microphone, so we can record automatically audio and speaking of this person. So with artificial intelligence, with this configuration, which is again my vision, I hope one day I can implement all these things in the same 2 hours class. With camera, we can actually perform face recognition, as I said before, emotion, speech recognition, gesture recognition, activity recognition from all the participants in our classes. So if we have 10 participants following my class for 1 hour, we have 10 sequences of emotion, 10 sequences of faces, speech, gesture. So we have a very multidimensional, large sample size information for us. And this is qualitative information. Then how can we use knowledge representation from artificial intelligence with this information? We can extract conceptual maps. We can start analyzing a relationship among these maps developed automatically for each individual. We can start creating semantic work, and this support the development of ontologies and taxonomies. With machine learning, we can actually perform emotion recognition. So we don't need to code anymore and analyze visually all the emotion of this 1 hour sequence of video. The machine can do this for us. So this 1 hour video is translated in 1 hour of chunks of emotion for each person. We can do activity classification. So based on all this information for 10 people, from 10 people, what they are actually doing. So the algorithm, the model, the AI model can actually say, hey, they are performing a collaborative activity because they are more interacting with each other, or they are listening to a person because is the goal of that conversation at that moment, or they are divided in groups and they are working collaboratively in groups. Machine learning can help do text and image analysis. Remember that we have a video of things that are happening, and a video is just a sequence of a long sequence of images. So from images we can actually extract text, but we can actually extract way more richer information. We can do then text classification. If each person produce, for example, on a tablet some text, this text can be analyzed straight away. And then, for example, we can do sentiment classification. What is the sentiment of each person in the classroom? Are they actually enjoying? And are they sleepy? Are they hungry? Are they sad? And if we collect these emotion sequences of emotion for 1 hour for each participant, and we kind of do an average, we can actually see if our methods, our teaching method are actually powerful. Because if everybody is sad, there is something wrong in what you're doing. If everybody is engaged, then we are succeeding as instructor. Then with artificial intelligence, we can all of a sudden enable argumentation among these people. We can see how they reason in a group. We can perform discourse analysis. And then we can, with artificial intelligence, we can start planning things. Imagine these 10 people are discussing some things about ethics of artificial intelligence, ethics of information. And as a group, they are trying to organize knowledge and try to plan the best, for example, policies. So with the artificial intelligence and its subfield of planning, we can do topic planning, we can do resource planning, we can do action sequence planning. And eventually, we can use elements from natural language processing, because we can do text analysis. If people write something in their tablets, we have this text automatically coded, and we can perform text sentiment analysis. We can extract arguments, for example, when they talk about ethics of information, and we can do this automatically for each text associated to each person, each participant in a group, and then use these arguments that are automatically extracted in a dialogical structure to extract meaning, to extract concept, to extract the similarity between concept and meaning among different participants. And then we can mine argument, we can extract rules, and we can eventually discover the main theme. And this is all done automatically. This is my long-term vision. It will probably require many researchers to help this, but with this picture, my goal is to summarize what is the state of the art of artificial intelligence and how this can actually empower us as humans, empower us as researchers, empower us as qualitative researchers, and empower us as teachers. So eventually, this is how artificial intelligence can actually empower education. So I hope you have enjoyed my my slides, and thanks for listening from all over the world and all these countries. I hope I was not that boring, and I'm happy to answer all of your questions. Thank you very much.